All right, starting chapter 4 today. Chapter 4, writing and graphing inequalities. 4.1 is our first section here. So we're moving from a chapter that had equations into a chapter that has inequalities. And other than the fact that we have to graph inequalities, not much is changing. We're going to later this week solve one-step inequalities, just like you solved one-step equations. And we're going to solve two-step inequalities, just like you solved two-step equations, but that's later in the week. For today, we're just going to write and graph inequalities. One thing you don't have to do with an equation is graph it. Because if you graphed an equation on a number line, you'd put a dot on the number that's the answer. That's pretty boring. Here, we're going to either do a closed dot or an open dot, and we're going to shade one side of the number line. Okay? That's because an inequality doesn't tell you an exact number. It gives you a variety of numbers that are possible answer choices. So inequalities are mathematical sentences that compare expressions. There's your first word, compare, or compares. And it's an inequality, not inequality, so singular. So an inequality is a mathematical sentence that compares expressions. Here are the four inequality symbols. This chart's going to be super helpful as you're doing your homework tonight and writing these down. Obviously, everybody's familiar with the greater than and less than signs, okay? Sometimes referred to as fewer than and more than. We're less familiar with the greater than or equal to, less than or equal to signs. And not so much not familiar with the signs, but the other terminologies that go with them. For example, the phrase at most or no more than both refer to being less than or equal to. If I said that I can fit at most 4 people in my car, can I fit 4 people in my car? Yes. Can I fit 3 people in my car? Can I fit 5 people in my car? Not comfortably. So if it says at most or no more than, that means there's a max number and all the lower values are possible answers, which is why we're using the less than or equal to. So I can fit 4 or less people in my car. For the greater than or equal to symbol, we have these phrases at least and no less than. I need to get at least a 60% to pass the class. Can I pass the class with a 60? Yes. Can I pass the class with a 64? Yes. Can I pass the class with a 58? No, because it's not at least 60. So when I say at least or no less than, that means there's a minimum number and all the greater values are possible solutions. So that's why I use the greater than or equal to sign. So these phrases are going to be the trouble points in tonight's homework. How do I turn a mathematical sentence into an inequality? So that's what we're going to do with the first part of the lesson. We're going to turn some of these words into inequality statements. Part A says there are at least 23 cats in my driveway. So I'm going to use the variable C to represent the number of cats. I know there's at least 23. Does that mean that there could be 23? Yes. Does that mean there could be 21? Does that mean there could be 28? Said at least, right? So the number of cats in my driveway is going to be greater than, but you said it could also be equal to. So I'm going to use the greater than or equal to symbol. If I could write it correctly, that would be super helpful. Also, you'll find the phrase at least right up here underneath where the greater than and or equal to symbol is located. So this is why I think this chart's going to be really helpful as you're doing your homework tonight, to refer back to it. Example B. I have more than 5 brothers and sisters. I'm going to use S for siblings. If I said I had more than 5, does that mean I could have 5? Not total. Could I have a total of 6? Could I have a total of 2? No, because I've said more than 5. So more than is another way of saying greater than. That one's pretty obvious. If I see more than, that means greater. So I have more than 5 siblings. Could be a total. Now, when I said 5, that means, yeah, of course you have 5, but not a total of 5. That's what I'm referring to. You could have a total of 6, you could have a total of 7, anything greater than 5. Example C, there are no more than 3 croutons in my salad. It's not a very good salad if it doesn't have croutons. There are no more than 3. C for croutons. What mathematical symbol am I going to use for no more than? That's right, less than or equal to 3. If there are no more than 3 croutons, that means 3 is the maximum and you can't exceed that. So it's got to be less than or equal to 3. You can also find the phrase no more than right there under the less than or equal to symbol. Example D, there are at most 115 students in our hallway. At most, S for students. There are at most 115. What symbol do I want to use, Ashlyn? Like that?
Yeah.
Okay. Okay. That, you're right. That is called the less than or equal to symbol. It's the same symbol we used in the previous example. So when I say no more than or at most, those are both phrases that refer to there being a maximum number. The maximum number of croutons I saw in my salad were 3. The maximum number of students in our hallway were 115. So I could have that many. I want to make sure I include the equal bar, or I could have less than that. And so you can find the phrase at most right there, again, under the less than or equal to symbol. People will get these wrong because they key in on the words most and more. And so if you see most and more, what symbol do you think they usually put? Yeah, they put the greater than or equal to symbol. But it says no more and at most, meaning you can't exceed those. So it's got to be less than. And for the same thing, when it says at least, that means no less than. It can't be any smaller. So it's going to be greater than or equal to. So think logically about those phrases, and we have to get more comfortable using them. All right, let's continue going. Oh, I never wrote the 115. My bad, 115 students. Example E. Twice a number y is more than negative 2.5. Parker, how do I write twice a number y? Times what by 2? Y. There you go. So how about 2y? Does that work? Okay. And Hannah, when it says more than, what symbol am I going to use? The greater than symbol. Yeah, it didn't say no more than. That would have actually switched it to the less than or equal to symbol. It just said more than. So that's greater than negative 2.5. On Friday this week, we'll talk about how to solve inequalities like this. Now, if that were an equation, Maddie says if this was an equation, what would you do to both sides to get y by itself?
So you would divide it by 2.
Exactly. Sounds like Maddie already knows what we're doing on Friday. Yeah, it's going to be a big repeat from what we did last chapter. Yep. Example F. Bryce, I'm going to read this to you, and then I want you to tell me what to write. A number q plus 5 is less than 18. What do I write? That's 5 times q. It didn't say that. Okay. Is less than in this instance doesn't mean I'm taking away from it. It's is less than. Is good. You got it. Nice job. On Thursday this week, we'll talk about how to solve inequalities like this. Georgia, what do you think you would do to get q by itself? If this were an equation, what would you do? Put negative 5 on both sides, get 13. Seems like it's going to be a lot of repeat later this week. Now, we didn't have to use our calculator or anything we just did. We just had to write the words they gave us. This next portion, I'm probably going to use my calculator on. That's because we're going to be talking about solutions of the inequality. So a solution of an inequality is any value that makes the inequality true. Any value that makes the inequality true. So with inequalities, unlike equations where there's one answer, inequalities have an infinite number of answers. If I said that a number is greater than 5, there are an infinite number of numbers that are greater than 5. So if I find a number that works, it would make that true, and that means it's part of the solution set. So look at example A. This is not an inequality that we're going to solve today, although we could solve this. We're not going to. What we're going to do today is we're going to take the number that they give us. Here it's -2. And we're just going to decide if -2 makes this inequality true. When it says, is it a solution? It's saying, does -2 for y make this true? So I'm going to take -2 and plug it in for y, which would give us -2 minus 5 is less than, or sorry, greater than or equal to -6. -2 minus 5 is the same as -2 plus -5. Keep change opposite. And what's -2 plus -5? Branson's the only one that knows, apparently. So -7, that's right. Join forces. -7 is greater than or equal to -6. Would you agree with that? Why not? You're right. It's less than. -7 is actually smaller than -6. If you look at the number line over here, you'll see -7 on the left of -6. And we know all the small numbers are on the left side. And so this inequality is not true. And so the answer I'd go with then is no. Is it a solution? No, because it doesn't make it true. Solutions only will make the inequality true. I'm not going to plug in some random number, have it not work, give me something wrong, and then say that's a solution. So show your work and decide whether or not it makes the inequality true. Okay, let's look at the next one. I'm going to plug in -2 again. It's going to go right here for y. So -5.5 times -2. I put that in parentheses, so I'm showing that I'm multiplying, is less than 14. Well, I have a calculator, so why not let the calculator do the work, right? Now, save yourself some trouble. Don't be completely reliant on the calculator. What's a negative times a negative? A positive. So I don't need to write the negatives when I'm typing this out. I mean, you could. I don't need to because I know it's positive. So I could just do 5.5 times 2. What is 5.5 times 2? It's 11. Yeah, my calculator helps me with that. So 11 is less than 14. Would you agree or disagree with that? 11 is less than 14. Agree? Okay. So this one is going to be a solution. Yes, it is a solution. So a couple things about the calculators. The calculators are great for eliminating any of our side work. I'm not going to ask you anymore to go off to the side and do long division, or go off to the side and line up the decimal points, or go off to the side and multiply those decimals, or go off whatever. I'm not going to ask you to do that anymore. I am, however, going to ask you to tell me what you're still writing in your calculator. So when I'm doing problems like this on my homework, I want to make sure I'm still showing that I'm plugging the number in, and then what I get when I do plug it in. I don't need you to go off to the side, but I do need to see what you're typing into your calculator. So there's still some work to show, just not any side work. Does that make sense? When we solved equations and you had to put -3 on both sides and then divide by 6 on both sides, we're still going to do that. I'm just not going to need you to do any of the side work if 6 doesn't go into 19. Okay. All right. So there is a few problems on the homework. We'll take a look at them in a second where we can use our calculator, but most of them don't require a calculator. And some of them, we're going to be lucky enough to get a few problems where we are graphing on a number line, just like you did in the chapter 4 opener, which, by the way, the chapter 4 opener due today by 2:30 if you haven't submitted that. Make sure that gets turned in. No work paper, just graphing on the number line. That was it. The graph of an inequality shows all the solutions of the inequality on a number line. And so we shade in parts of the number line and we use what we call open and closed circles. So an open circle looks like this. There's no shading on that dot you put on the number line. You have to, it's actually bigger than a dot. I put bigger dots in. So it's actually a circle. Open circles are used for less than signs and greater than signs. This would show that my variable is less than the number I circled. This would show that my variable is greater than the number that I circled. So what's important to note, though, is that there is not an equal bar. The number that you're circling is not part of the solution. Whereas if I have a closed circle, the number that I'm circling, I'm shading in, it is part of the solution. And that's because we have the equal to symbol right underneath our sign. So if we see that equal bar, we got to shade in our circles. And if we don't see it, we're going to leave them open. All right, example A. Just like what we did on the chapter 4 opener. Except on chapter 4 opener, they already had the numbers filled in on the number line. So what I'm going to do is I'm going to take -1, put it right in the middle. The reason I wanted to help you guys, or why I wanted you guys to help me fill in the number line, is because it gets a little fuzzy when you start working with negatives. Thomas, what's the next largest number from -1? Yeah, what's the next largest number? No. What's one number larger than -1?
Oh.
There we go. Okay. And if you were thinking -2, well, I understand why you would do that, because 2 is normally the next biggest number than 1, but this is negative. -2 is actually the next smallest number. And again, that's because we're working with negatives here. Okay. Thomas, a chance for redemption. Do I want to use an opened or closed circle around -1? That's right. We're going to leave it open because there's no equal bar. And then Maddie Cheeseman, is A bigger or smaller than 1? -1, sorry. It is smaller. That means we're going to shade all the smaller numbers, which are always on the left side of the number line. Okay. So when we work with inequalities, I think the easiest way to decide what direction you're graphing is just to ask yourself, is the variable big or is the variable small? Is A big, is A small? You can tell, I mean, you guys learned several years ago about the hungry alligator, right? What's it tell you if the hungry alligator's refusing to eat A? It's A's smaller, too small, right? Too small. So if A is small, I shade to the left. If A is big, I shade to the right. Parker.
So do you see how how it looks like an arrow?
Yes.
Does it work every time?
Not every time. I'll get to that in just a second. Okay, it doesn't work every time. So yeah, I'll talk about that. All right, example B. B is greater than or equal to 4. So I'm going to start by putting 4 in the middle of my number line. Branson, what's the next largest number? And the next smallest number? Do I want to use an opened or closed circle around 4? Yes, it's got the equal bar. So not only is it going to be greater than 4, but it's going to be equal to 4. So I'm going to shade that in. And then Ella, is B bigger or smaller? Bigger. So I'm going to shade to the right. Now I'm shading in the arrows too. That's not something that's a huge deal, like I would count off if you didn't shade in the arrows of the number line, but it does signify that the number line does go on forever. So it's not just 4 and 5 that are possible solutions. It's any number larger than 4 and equal to 4. So it could be 1,487.62. It's a possible solution, right? It goes on forever. Example C. We're going to put 6 right in the middle, 5 right below it, and 7 right above 6. Hannah, do I want to use an opened or closed circle around 6?
Okay.
That's good. And then is the variable C bigger or smaller?
Bigger.
Hungry alligator won't lie to you. Hungry Alligator says, give me C, right? So that means if it's bigger, we're going to shade to the right. Now, this does bring up a good point, and this is what Parker was alluding to. After you start doing enough inequalities, you start to pick up patterns. Okay, we're good at doing that, especially in math, right? We pick up patterns. One pattern you'll notice is that when the symbol points to the left, you shade to the left. When the symbol points to the right, you shade to the right, except when that's not true. So how do I know the difference? Well, what's different about the way that A and B are written versus C? Georgia? Yeah, so in A and B, the variable's written first, whereas in C, the variable's written at the end. So that flips things around. So instead of giving you a shortcut, says, hey guys, just shade whatever direction the arrow is pointing, except when the variable's on the other side and the opposite, that's just too much. Instead, ask yourself this question. Is A bigger or smaller? If the sign's opening up away from the variable, that tells you it is smaller. Hungry Alligator is refusing it. If the sign opens up towards the variable, that tells you that it's bigger. Why does that matter? Well, if A is small, I shade to the left. All the small numbers are this way. If C is big, I shade to the right. All the bigger numbers are that way. That way I don't get confused about what side the symbol's on. Okay, so on example D, is D bigger or smaller? Bigger, so I shade to the right. Don't try to trick yourself about what side the inequality the variable's on or what direction the arrow's pointing. Those aren't questions you want to ask yourself. Instead, the question that works no matter what, doesn't matter what side the variable's on. Is the sign opening up towards the variable? Yes. Okay, so it's big. Is the sign opening up away from the variable, like in this one? Okay, so it's small. That's what you need to look at. So in example D, I'm going to put -10 right in the middle. Aiden, what's the next smallest number? Good. And the next largest number from -10? Excellent. Aiden, would I use an open or closed circle? Good. And since we said D was bigger, we're going to shade to the right. That's the easiest way when you're graphing. Don't worry about what side of the equation or the inequality of the variable's on. Don't worry about what direction the arrow is pointing. Instead, ask yourself, is C big? Yes. Is D big? Yes. Shade to the right. Is A bigger? No. Shade to the left. It's smaller. That's way easier than trying to confuse yourself. Now, in these 4 problems, I gave you the inequality and we graphed them. Here, we're going to do that. We're going to work backwards. Instead, I'm going to give you the graph and we're going to write the inequality. It says, write the inequality for the graph, then describe all the values of X that make the inequality true. All right, so I'm going to use the letter X for my variable. Is X greater than or less than -2? Yeah, remember everything that they're shading right here, that's X. X is what's being shaded. The variable always represents what's being shaded. So if X is on the right side, if everything being shaded is going to the right, that means X is bigger than -2. Is it also equal to -2? How can you tell? They shaded it in. So I'm going to use a greater than or equal to sign and then put -2, and that's it. X is greater than and equal to -2. You can tell because they use the closed circle. Now, if they use an open circle, like the next one, I'm not going to put that equal bar. They also changed something else. They also changed the direction that X was being shaded. So now instead of saying X is greater than, it's now shading to the left. We're going to say X is, what's the same as saying smaller? X is less than. X is less than -2. And we're not going to put the equal bar. Example C, they flipped it again. X is now greater than because it's shading to the right. Did they close in the circle? No, they didn't close in the circle, so I'm not going to put a little bar underneath my sign. And last one, example D, they shaded to the left again. That tells you X is what? Less than. X is less than, and they shaded it in, you're right, and they shaded in the circle, so we're gonna put the or equal to sign underneath of it. So on your homework tonight, you will have to write an inequality from a graph the inequality from, graph the inequality from what's written. You'll have to show some work, maybe use a calculator to see if solutions are the value you're plugging in is a solution to inequality. And then a lot of more writing it. So your calculator is not going to be used a whole lot in tonight's homework, but a little bit. Most of it's just going to be writing it down. Yes, you do need a work paper. No, you do not have to draw graphs on your paper. Okay. I'm not going to make you draw any graphs, just like I didn't make you turn in a work paper for chapter 4 opener because it was all graphs. 8. Okay. Good question. Oh, let me go ahead and turn this off.